So I'm James, this is Alan. We're going to talk about Chef Action. So this is something we've been working on for the last 2 or 3 months, and we sort of want to give you a first look at it. One of the things that we really knew, when you look at the Chef server, is we have a lot of data. We gather a lot of data. We worked on the node run history stuff, where we gather every change that's happening on your server when you're doing a converge. And the same amount of data is available as well whenever you're doing actions on the Chef server. And we've never been very good, or in fact, we've never exposed that data in a way that's particularly easy to integrate with. There's lots of sort of ghetto solutions, mining the Nginx logs, things like this, kind of trying to go around the back door. So what we tried to do here was design a product that really tries to let you answer questions about what's happening. And the very first thing we want to do was just what's changing on your Chef server, So we're trying to tackle the very obvious questions for clients, cookbooks, data bags, the objects on your Chef server. Who changed it? What did they do? When did they do it? And try to give you some way to start to correlate that information to other things that are happening on your server, like runs. It's not an audit solution, and that's because I'm really afraid of the word audit and everything that comes with it. I think it's a step towards an audit solution. It's sort of one of the primitives that we need. It's not right now something that we would guarantee we're going to get every message. Some component could go down. We're not going to have full provenance. We're not going to be able to do it. But we're trying to provide a read-only view that could become an audit solution as we strengthen it and as we get all the features in that sort of thing would need. We want to sort of enable 2 modes of interactions for you. One is that as events are happening, we want you to be able to react in real time to them. So when a cookbook's uploaded, we want you to get a notification or give you a way that you can actually do something based on that. And secondly, enable you to do the after-the-fact investigation. I think Heartbleed last week was a really interesting case. As I've talked to customers about this, they keep going, if I had this last week, when I had to work out which versions of SSH was where, and then after that, work out which ones had been updated until we had none of that versions there anymore. So it's trying to let you answer those questions. What happened just before all our nodes started doing a failed run? What happens before DepSolver broke? Who was the last person to upload a cookbook before DepSolver broke and we couldn't do anything? So trying to give you the data so that you can answer those questions. As well, I think, we're going to talk about this. We can talk about this and all the sort of areas of analytics as well, and really just stick up your hand and, ask questions as we go. We don't really want to just talk to you and then questions at the end. If you have questions as we go along, if you want us to dive into more detail in any piece, we're more than happy to do that as we go. And there's 2 of us, so there'll always be one keeping an eye out there, at least to see that nobody's sleeping, at least if they're not asking questions. So what does the architecture for this look like? So we have all our backend services running inside Private Chef. So we have Chef, OC account, we have the reporting system. And we've added in an instrumentation component into each one of those that runs at the end of the HTTP request. And what it does is drops a message into Rabbit. And then we have an analytics pipeline that's reading out of Rabbit and doing processing to that message afterwards. You see notifiers along the bottom. We have this action messages component, which is basically a HTTP service that's accepting posts of these processed messages, serializing them out to the DB, creating a DB structure that we can then do fast, efficient queries, and then a web client against that. So let's have a quick look. So Mandy demoed some of this in the keynote yesterday when Barry was doing the keynote. I just want to sort of point out some more of the things here. So what you see here is a series of actions which I did yesterday. Uploading a bunch of cookbooks, deleting clients. So this was I have a little test script that's going to create some roles, upload some cookbooks via Bookshelf, do a couple of kitchen converges that are against the box, throw up a couple of nodes and let them do a Chef client run. And this has captured all the information. So what you get here is that we have some sort of tagging. So here we're doing user agent tagging. We're looking at what user agent actually did the command. Was it knife? Was it Chef client? Was it Bookshelf? So you can start to filter out things that were part of a Chef client run against human interactions because you want to treat them differently. You might want to alert on them differently and have different audit around them. We have a filtering system here, so we can say, show me only the updates, and here we go. So now we're seeing some of the bookshelf runs that they were doing as part of the demo here, and let's say I want to see deletes as well. So we're getting all the deletes, all the updates. All of the query and filtering is being done on the back end via the API. So all of that's available programmatically. You can see the URL at the top. So this URL outside of the web application will return you back a JSON object which matches to the exact result set that we're getting here. And we'll show you some of that later on. So again, it's all about accessibility. Whatever we show you in the UI, you should be able to access directly via the API as well, the query interface. You can search on different times, so show me everything since today, and we're just going to see that last thing that I did. We have export as well, so we will, whenever, again, the exact same principle applies. Whatever the query is that you see here, you can export that as CSV, tab separated values, or JSON. When we release, we have some stuff that we haven't gotten demo yet. We'll have an email button. Click here. It's going to form an email so that you can instantly send it to some people to say, here's something. Here's a subset that I've narrowed the problem down to, and then notify it. So it's all about giving ways that you can bring people into the conversation about what happened and try and fix the problem if there was a problem or do some investigation. We have saved searches as well. So again, the exact same principle. You're going to be able to do pre-canned searches. Show me all the cookbook updates, and show me who did them. We have linkage, so we still have Management Console, and of course, analytics gives you some sort of real-time view, and often what you want to do is sort of drive down into slightly more detail. Let me reload. So one of the things you might want to do is you've just seen that this user has been created, this data bag's been created, and you want to go over and see it and manage. So we have navigation back and forward to manage and back from manage. So it does deep linking into manage and drops you right on the object, and you can see what's there. One of the nice things you can do is actually, here's the live demo. Can I type JSON? We also have HipChat notifiers. So this is the data bag item I just created. So we have live notification of what's happening coming into HipChat IRC or whatever feed you want as well. So that's it for the demo. Are there any questions on that or anything else?
Do you have an API or knife plugin or anything that also works?
We have an API. We don't have a knife plugin yet for it. One of the things here is that what we've done is we're not doing the security with knife credentials. So we're looking at using OAuth 2 for it.
Right.
So you're going to be able to do it in knife, but actually without having credentials. You're going to be able to do it from other things as long as you have a bearer credentials and OAuth bearer credentials. So we want to move to the way where you can actually have some sort of application that can actually get some credentials and then do these queries against the API as well.
Right. Part of our automation deploy, we interrogate the chef server before we upload. We know our changes. This is going to be very helpful that after the chef plan runs, did it actually happen?
Yeah.
Right. Exactly. Yeah. 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 At the back.
Yeah.
We'll come to that. Yeah, we're trying to give you a way so that you can specify that. And that's sort of something that we're interested in discussions with. We have an approach, and I'll let Alan talk to that.
You can yell at me then.
Yeah. Was there another question? No? Okay. So over to Alan to tell you all about that piece.
How do I... Thanks. So I'm going to talk about our event processing pipeline, basically how data is coming out of Urchef and what we're actually doing with it before you see it in a client, like the web app that James just showed. And I would add one thing that James didn't mention about the web app that I think is important. One strategy we try to take is we're the first consumer of this API, meaning basically anyone could have written the web app that we did, and including soon-to-be authentication. It's pretty standalone, and it's actually sort of shaped how we modeled that API. So we're using Rabbit as our queue. All messages are being piped from Urchef straight into Rabbit. It then goes into this pipeline, which then goes out into a million different places. Our message format's pretty simple. I think we would describe it as sort of the metadata about certain chef runs. So here we have version 2.8.1 of our Apache 2 cookbook was updated. We have the organization name, we have who actually modified it, the service host name, we give it a unique ID so it can be found. And then this is our actual event architecture. So coming off of Rabbit, it goes into a parse stage, which is that metadata is unmarshaled, it's correlated with some other data. We then go into a tagging or classification stage, then the notification stuff that James was talking about, our webhook system, which I'll get to in a second, and then it's persisted for querying. So the first step is the classification stage, which is tagging. So tags can are either from the user, so when you label a node, for example, but we're also adding our own tags. And sort of we think about them in two different groups. The first is sort of the static and dynamic analysis properties of the resources being modified, and then there's the predictive or probabilistic model. So around static and dynamic analysis, we're looking at a few different things. One is conformance. Everyone we talk to, all Chef customers that we deal with have internal style manuals for Chef. And one of the things they want to know is sort of, I have this opinion that's sort of radically different than others. Is it the best way? Well, we want to give an empirical way to look at that. Next is coverage. While we are getting to the point where test coverage for Chef is like a real thing, what does actually coverage mean? I mean, coverage for configuration management is very different than an application. We don't just look at sort of code execution, because a lot of Chef configurations shouldn't have all code execution. So we have to look at different things there. And moreover, is having high test coverage actually good? Like, is there a threshold that you should be aiming for? Third is style. Chef is nice where we have internally consultants who work with customers, teaching them best practices, and actually they end up learning a lot about what we build and basically what we should change. And they can inform sort of rules or our style that we can say, hey, look, you can improve this aspect of your development. And then finally is typical static analysis stuff, which is, are you making just basic syntactic and semantic mistakes, which might blow up your infrastructure. And then finally, we have sort of the supervised learning stage, which when I came to Chef, one of the things I was thinking about around analytics is I was working before then, working on diagnostics in medicine. And the statistical problems in medicine are really complicated because you have actual outcomes. Someone lives, someone gets better. You have a lot of variables, but the variables are they're inconsistent. If your doctor asks you your health record and you may omit things, you may not remember things clearly, and it becomes a mess. So basically, trying to pull stuff out and making sense of it, even though it's all pretty hazy. And that's actually pretty similar to sort of the infrastructure problems. A lot of my friends are operators, and some of them are in this room, and it's like, it's magic sometimes. It's like, because they've been in this shit, they sort of know best practices, even though they can't sort of articulate them in a clear way. Well, that's one thing we're going to try to do. Then the next phase in our analytics pipeline is, the first part was around sort of prediction, forecasting, and sort of just the empirical view of your infrastructure. The next is monitoring. We really wanted to create sort of a monitoring tool that we would actually use. And sort of when we were evaluating them, It's like, well, what stuff do we actually enjoy using that we actually get some benefit from? And as you might have noticed from these two examples for our email and IRC configuration, Travis was like a really good example, where it's super simple to set up. Here's your hip chat question. You can give it a formatted string with a bunch of variables that we expose, and it just works. However, that doesn't work for everyone. I was in a meeting yesterday, in fact. It was for a big company, and they said, oh, the notification stuff is great. It's going to be really useful. But we have something like 50-odd notification services that we want to pipe all this stuff to. We at Chef use a lot. Like, we use maybe 24, but, so they were like, oh, will you support them? And my answer was no. Just because it would just be impossible. But we do think we have a good compromise, which is we are exposing webhooks, and services can be written that we will post not actually just the formatted message, but the full copy of the message too. And when we release that, we have a few sort of starter projects for you to build from. Next is an alternate way to sort of create metrics, right? So this is a metric I created using the same sort of YAML syntax that we're using for notifications, just to basically get people who want some more exposure on Chef runs to be able to actually write metrics and use them. And in fact, this is creating the same query that you could actually create this in the web app, and they're going to be identical. This is just another way to do it. And for this one, it's actually a real question I had, which is like, what's up with James's weird hours? So on actions, create, delete, update, actor, James. I was only interested in cookbooks. And then here you can give statistics. There's about maybe a dozen odd statistics that we'll have. Here, frequency, which is count, and mean. And then we actually have some group by stuff. So, give me an hourly time series of that. Finally, the last stage of our event processing pipeline is persistence. One of the things sort of working on analytics problems like my entire, professional career is big data is often never big. I've worked in finance, I've worked in medicine. I've never seen scale, which needs very, very large infrastructure. And when we were actually doing the math to figure out sort of what can we do for persistence, turned out Postgres was a good option. And it just kind of makes me feel good that we're not actually going to make anyone deploy, sort of a Hadoop infrastructure. Finally is the API that we expose. So while we think a lot of people will use our web app, they'll use sort of the configuration tools that we'll offer, we are exposing an API. And like I said, with the web app, this is the API we're using. So here's an example query. So create, delete, update on environments for prod, before, and since. So give it an interval. And the response here is a hypermedia response with good unique identifiers, URLs, etc. So we hope people build interesting things with it, which the Chef community has always been good at. And we'll be offering clients for this API, of course. Here's an example of the example I gave earlier, done in our Ruby client. So you create a client, and then a very active record-like sort of type method chain for finding, create, delete, update for James and cookbooks. And then finally, getting the frequency in the main as a JSON object or an array. A map, sorry. And our thinking with our Ruby client is this is what people will use to build their internal dashboards and such. And another client we have with probably a different use case is our R client. So very similar syntax, but more R-like. And then finally, giving a summary. So that's, if you're not familiar with R, that would be sort of the 5 statistic summary, quantiles, mean and count, which we imagine sort of anyone doing analytics around operations will use. So they don't actually have to interface with, sort of a weird API that they don't understand. And moreover, our client is actually fixing a lot of the stuff that we sort of hate in current sort of monitoring analytics tools. Like this will handle missing values appropriately, will handle time series objects appropriately. And so you can actually do regression in a sensible way. And then talk about how we integrate through this event pipeline.
Back to me. Yeah, so I think integration is a big part of the story, really. So, like, what we want to focus on is a stable, reliable, performant pipeline, and allow the community and the users to build out their specific logic inside and communicating with that pipeline. We've seen there's a whole bunch of different places where you can integrate. You could just consume our raw messages coming out of Rabbit.
Yeah, I was going to ask that because we're a big Rabbit shop and
Yeah.
lots of tools around that.
We could also, instead of posting to HTTP at the end as well, repost to Rabbit with all our classification and things like that. If you wanted that sort of logic.
Well, I'm liking the fact that you already do parsing and the JSON formatting. There's Goodman that we're inventing that wheel in some part anyway.
Right.
Yeah,
Right.
totally.
So you could just be a consumer, just like our analytics pipeline, and just take the raw feed. If you've got something that you can shove that all into. There's notifications where we're going to interface with where you want a description, a message. We can format that, give it to you, and interface straight away. And it's a really simple integration point. Webhooks for people who are really going to build systems around this. The type of stories we've heard back from customers so far, like in the ITSM world, being able to send things to their asset database, being able to send things to their monitoring systems, all that sort of thing. So CMDB systems, and that seems to be the sweet spot for the webhooks.
Would you be exposing the parser? Because I'm already seeing ideas for us. We use Vertica to capture all our current metrics and alerts now. We tie off RabbitMQ, parse it, and which fits our Vertica database structure. We could feed off Rabbit, but still run it through your parser.
Yeah, I think it's what James was saying before. Is we don't right now, but we could. We could put it at the end of the.
We could send it back into Rabbit again with all the stuff.
And that actually probably makes a lot of sense.
We actually do that very thing.
Okay. Yeah.
Consumers,
Yeah. I mean, equally, our idea with sort of the stub clients is we want to give you a little Sinatra app where it deals with all the receive, all the security side, and you're literally going to have a handler and it's like, get me the message, and it's going to give you a map, of what that JSON blob was, and that's it. And that then allows us, if we want to change the protocols underneath, if we do need to scale up, and if we have to move to protobuf or something else, at that level, it really doesn't matter. But I do think that Rabbit will stay as this sort of integration point. It's pretty key. So we've got webhooks, and that's where the meat is. You're going to get the full node object or whatever it is. There's some interesting things around node objects because clearly they're the thing inside the system that are just at a completely different scale. They're often megabytes rather than kilobytes. We've had a couple of different thoughts on this about what we do. The first one is that we could send you all of it or none of it, or you could do a partial search. Another approach is that we could send you just the attributes which have been set, but not the automatic attributes. Some of these different use cases fit things better. Like, let's say you want to build in something that tells you your operating system versions. Well, you actually need the automatic attributes, but you only need a few of them. So maybe partial search on automatic attributes plus everything that's actually set on the node. So you get the run list and all this sort of things. You can see changes. Sorry, could you repeat?
Yeah.
So deltas, yeah. So we're thinking about deltas. See, we have the node object. What we were thinking and what we've seen, so I don't know if the Schubert Phyllis guys are here, Sonder and Sonder. No? So Schubert Phyllis have built sort of something kind of similar to this, and they post it to Git.
Yeah.
And so one of the things we've been investigating is actually just running like a little GitLab inside this pipeline. And as the messages come through, we just send them all, and you get the diffs.
Oh, sure.
So what we would do as part of the analytics pipeline is we write the message to Git, we strip the body off and replace it with a SHA. And so what you're getting at the end when you do the query API is you're getting a sequence of SHAs. And then you can just ask for the diff between the SHA. The reason that we haven't got it here is that we don't really like the user experience of having to send you off to GitLab to show you that diff, and really we want to show it in line in our user interface. So I think it's a type of thing that would be a really easy webhook to write. And it's something that I think that we really would like to do, but you probably won't see it until it's sort of a bit more fully formed. But as an experimental webhook, it's not very much work to do. So talking about deployment, we support the same sort of HA architecture of Enterprise Chef in terms of front end and back ends. Right now, the only back end service is Postgres. The front ends, we have the bits that are the pipeline, we have the query API and the ingest service. What we're recommending now, and it's not completely necessary now, but it will grow as the data gets larger, is that you deploy it on a separate hardware than your Enterprise Chef. You could deploy it just on the same. We test it on the same infrastructure. But the database access patterns for an analytics application is very different from a database application for a kind of OLTP cruddy thing like Chef. So I think it's just safer to put it across. Some of the things that we're looking at is like if you're running multiple private chefs, like could we get it so that you only run one analytics pipeline and pipe multiple chefs to it? Because clearly, you know, when we look at analytics tools, the bandwidth and the number of messages per second you can handle there is much greater than any individual private chef would be generating in this sort of actions and reporting type application. So we're still playing around with deployment topologies. The first, in terms of the storage, no, it's Postgres only. So it's the same, right now it's the same model as for Enterprise Chef where it's an embedded Postgres. So it's an interesting question. Like when we looked at it, you know, this is still a small data problem and Postgres works. I think as we grow and at the point where we get to that level that we have to grow, then we will support alternative backends, Cassandra, things like this that are more relevant. For me personally, I don't want to build up an entire organization inside my team to develop and support Cassandra, Hadoop, Hive, and all of that. Like, right. Right.
I mean, it's definitely something we thought about. I mean, we're sort of hesitant, but we have intentionally kept sort of our object model simple enough where it, you know, we do occasionally ask, oh, would this make sense in Cassandra? Would this make sense in React? And so far, pretty much, yeah. But, I mean.
Right. I mean, to give you the numbers on this, so let's say you're running a 10,000 node Enterprise Chef cluster and 15-minute converge period. That's about 23 Chef client runs a second. So you're only getting maybe 100 messages a second. I mean, in one cluster. So one 10,000 node cluster, you know, like, so if you were deploying one analytics system beside one Chef, that's the number you have. And so in that sort of deployment topology, I think Postgres is a good option. As we start to say, you actually have 10 private Chef servers and you only want to have one analytics platform, I think that's exactly the point where we support the alternative backends.
My use case is that we are integrating with Chef to support customers.
Mm-hmm.
So our customers run Chef servers
Mm-hmm.
and pump data to us.
Yep.
So we have many Chef servers.
Great. Yeah, we'd really like to talk to you about that and sort of what your numbers and your scaling numbers are, because I think that's the point at which we switch to external backend stores.
Yeah, that's
okay.
good.
And so what we're doing is delivering a single omnibus package. We're hosting in a separate domain from where your management console would be. And this is, again, to start to give us this flexibility to run a slightly different configuration and topology. Like right now, if you look at the only interactions it has with Private Chef is it needs to know where the Rabbit exchange is that it's going to consume from. And in order to generate the links to the manage, it needs to know what the manage root URL is. And that's it. So it is very amenable to deployment on the side. There's not a lot of heavy coupling back and forward. So you don't really even need your etc. Opscode private chef.rb. You can just drop the values in and have it completely separate. But because all of our, I mean, we don't have a federated solution right now for Enterprise Chef, and I think like that sort of federation stuff would come along the time with that more than likely. We want to do it. We probably won't tackle it straight away. So the stuff we've shown you now is basically there or nearly there. It's either in the demo that we showed you or basically at the pieces that we can drop in. Let's talk about what's next. So right now we've only instrumented Urchef. So next is to instrument the account service so that we get ACL changes, group joins, group leaves, so that we get that metadata as well. Because as we go to an audit solution, that becomes key. Object diffs. This is exactly what we were talking about. We have object transfer. We need to work out exactly like what's the right solution for object diffs that we should embed versus perhaps an external one. Live feed to the UI. So we have a prototype running where we subscribe to Rabbit in real time whenever you connect to a URL on the backend server, and you get live requests coming back. So during a deploy, you can sit and watch what's happening as it comes out. It's really amenable to being in a dashboard in the office, that sort of thing. So what's actually changing? Aggregation's an interesting one. Chef 1110 client. So for those who used reporting before, you see this UUID, run ID that gets added at the end. And really what that is a post at the start of the message and a post at the end of the at the end of the run to tell you what happened. We now put that UUID on every API call. So we can now correlate API calls back to the Chef client run that they came from. That's also available for Knife. Less useful for Knife because usually it's only one. But node save and update and things, you do get calls. We're going to instrument Berkshelf for that as well, because what we think is important here is really a human view of the interactions on your service. You didn't actually upload 6 cookbooks. You ran Berkshelf one time and it uploaded 6 cookbooks. So we want to be able to aggregate all that together and give you the view of the action that happened. Because that's when it fits that mental model. If I come to you and say, you uploaded those 2 cookbooks, did I? It's like, you did a Berkshelf run about 20 minutes ago. It's like, oh yeah, that's what I did. Okay, let's go fix it. So trying to make it to change it from an API level thing to actually human-oriented action. Knife instrumentation is something that we're interested in as well. The input to this analytics pipeline we want to expose externally as well. So if you have the credentials, you can submit. Cloud plugins are the great use case for this. EC2 Bootstrap, we want to tell you when your your EC2 Bootstrap started, the Chef client run that happened during it, and when it happened, when it ended, or if it didn't end. So trying again to hook together all these different levels of abstraction that you can look at your instrumentation and automation and give you ways to link them together. For those of you who were in the roadmap session yesterday that we ran, you'll have seen this slide. So this sort of fits in the analytics team in general, and Chef Actions as one of the first analytics products fits into the sort of the premium features we want to give you inside Private Chef to help you do your job better and easier. And we know that basically compliance reporting and audit is one of those things that we could really help make better, easier, faster, and more successful. And the way that our roadmap really is working is that the first 6 months is building primitives. Chef Actions is the first primitive. We will probably have a primitive around attributes to solve this sort of thing of like, what operating system version do I have? Ways for you to express queries around that we can then track over time and track changes over time. Such that we're building primitives up that in Q3 we can start to offer you a compliance reporting system. A lot of the stuff we do is kind of influenced by the whole old IBM 7W model of who did what, where, when, to what, from where. And one of the things that we see is that fits really naturally into our pipeline. So if we go back to the event processing architecture, what we see is like auditing and compliance reporting is basically another step in this pipeline after the hooks, where you can define rules like Group A is only allowed to do operations on this or within this. The example I gave in the roadmap, which people seem to like, is nobody should update cookbooks after 5 p.m. So, nobody should push on Friday. So a way that we can report that sort of action against audit rules that you define for real time.
Priority to be human is allowed to push cookbooks on their automation tools.
Yeah.
Exactly. Great. So speaking of that, one of the things we want to do as well there is Many people are moving to using automation tools to push cookbooks, and of course we lose identity.
Right.
So everything looks like Jenkins pushed, which we're the people who suffer because our user experience suffers. Nobody else really cares until you expose this information.
Yeah, and where we've been playing the games is we know who initiated the job via Jenkins, and it's just a matter of carrying that.
Yeah.
Exactly.
Yeah.
So what we're going to do is give, I think, two things. A way that you can annotate extra information into your request with a set of headers that we're going to carry through for you. And the second is probably a way that you can, if you're a trusted entity, you can say on behalf of, and give some way to express that on behalf of relationship. So we trust your key at a slightly higher level. This is how the web UI, the management console works right now. We have one key, and it's trusted to do the switch. So we're looking at how we can stretch that trust boundary just outside of our products to your products, which you trust yourself. Clearly, that will never happen on hosted, but that will happen on enterprise. Yeah. So really what we're focusing on is this flexible analytics pipeline that lets us plug things in and grow more capacity over time. We know there's valuable data locked up inside your Chef server right now. We, with Actions, start to expose that to you with a whole range of APIs. It's not finished. It's not the final set of APIs. It's probably not the final set of data. But we think we've got an architecture that lets us, over time, incrementally release more and more data. We have a version of Chef Actions that's available right now for limited availability to some EC customers. We want to take a couple on board, and especially those who want to play around with the webhook type thing and sort of run them through the process. We want to open that up over time to more and more customers. And this fits into our defined roadmap that we have right now of like moving towards better audit and compliance solutions over 2014. So I think we've got a couple of more minutes for questions. Yeah. State attributes. Yeah, so state attributes are a part of node run history. And whenever we do a node run and go through the resource list, for any resource that changes, that actually triggers, we get the before state and the after state. So let's say you're writing an LWRP and you've got like 40 attributes and some of them are internal. State attributes give you a way to express, these are the things that I want to publish externally that represent the state of my system that changed. No. We store it, we at the end, we have a handler that runs across the resource collection. No, okay. We have an event handler that stores the objects that changed for us as we're going through it. And then we have a report handler at the end that goes through our change state and calls state attrs on each one of those resources and persists it to the reporting server. So on the reporting server right now, you will see like the message that we post is basically a list of resources, and it's a before and after block, what time it triggered at, what it did, and that. And that doesn't go through this right now, but I think that's one of our prime candidates for what we're going to start shoving through this pipeline as well, so that you can start triggering actions on did this resource change. Yeah. One discussion we've had with Dan is whether or not the state address is the right way. So we do an explicit whitelist right now, and it might actually be better to do a blacklist, and so flip it around and actually say we publish all the state unless you don't want us to publish it. So a bit like we've done to hide the secrets inside the client. So you can say a resource is sensitive and exclude the diff. So the model there might change in Chef Client, but as of 11.10, that's the way it runs right now. You annotate your resource with state address. Yeah.
Are the GUI and the data pipeline code open source?
No, it's enterprise.
Hit view source in the
We're taking a week's holiday after this, and after that we're gonna start. Come talk to us afterwards. We want to get a couple of customers who can do it.
Hosted and then into enterprise?
No, we're gonna give it to enterprise first.
Perfect.
You guys deserve one first for a change.
Yeah, thank you.
And actually, when you look at this type of thing, it's much more amenable to enterprise. We'll run it unhosted as well. Sure. But in terms of analytics pipelines and cross-org stuff, it's actually
Finish our migration to Chef 11. I will definitely be making a phone call. So.
great. Okay, that's it. Thank you.